is a simple problem. Volume of atoms present in face-centered unit cell of a metal. Radius R is the atomic radius. Coming to question number 12. The volume of the atoms present in a face-centered cubic cell, unit cell of a metal. The radius of the metal is equal to R itself, that is given. The crystal structure is FCC. In case of an FCC lattice, there are 4 particles or 4 atoms. What is the volume of the 4 atoms? Volume of each atom is 4 by 3 pi r cube. Volume of each atom is equal to 4 by 3 pi r cube. In FCC, 4 atoms are there. Therefore, it is simple now. Volume of particles present in FCC is equal to volume of particles is equal to 4 into 4 by 3 pi r cube, or it is equal to 16 by 3 pi r cube, and option 4 is the correct answer. It's a simple problem. Anybody can do this. 16 by 3 pi r cube. Now, question number 13. Every atom or ion that forms an FCC unit cell is surrounded by. This requires the correct picturization of an FCC unit cell. Okay. Every atom or ion that forms an FCC unit cell is surrounded by. We'll consider now the FCC unit cell. You can consider any atom. Every atom means any atom you can consider. Let us consider this corner atom. It is surrounded by how many tetrahedral voids and how many octahedral voids. That is what is asked. Question number 13. Every atom or ion that forms an FCC unit cell is surrounded by. Answers, alternative answer, 6 octahedral voids and 8 tetrahedral voids. 8 octahedral voids and 6 tetrahedral voids. Likewise, other 2 alternatives are given. Before finding out what is correct, we will try to understand here. Now, this is the corner atom, and actually this is the octahedral void. There is an octahedral void here, this is here, this is here, this is here. By that, what you can understand, octahedral in an FCC, edge center is the center of the octahedral void. So, octahedral void is present where I tell there, it is the gap between the 2 particles here, 2 corner particles, or the center of the octahedral void lies at the edge center. All the edge centers are the sites for octahedral void. Now, we will consider any one octahedral void. We will consider this particular octahedral void. It is surrounded by how many particles, or what is asked here, how many, each particle is surrounded by how many octahedral voids. It's the other way. Now, they will consider this particle. For this is one octahedral void, this is another octahedral void. There are 2 octahedral voids are here for this particle, and one more octahedral void is here. So, 3 octahedral voids for this particle. Now this particle is also common for one more cube which is in front of this. So, likewise, what we can say that any corner particle is surrounded by 3 plus 3, totally 6 octahedral voids. So, it may not be that clear there. I will write the diagram out. I can make out. FCC can be written like this, or this is the cubic. Now, this is the particle, and this is the site of octahedral void. This is the site of octahedral. This is also the site of octahedral void. It means for this corner particle of this unit cell, there are 3 octahedral voids surrounding it. 3 octahedral voids of the same unit cell surrounding it. Now, we need not consider of this. It is not given in the problem how many octahedral voids of the same unit cell are surrounding is not asked. Any particle in FCC is surrounded by how many OVs and how many TVs is the question. Now this particle is also surrounded by nearest another octahedral voids, which is the edge center of the another unit cell. You consider another unit cell. This is the corner particle, which is common for both. These are the three octahedral voids of the same unit cell. This is the fourth octahedral void of the neighboring unit cell, and this will be the fifth octahedral void. This is the edge length. Edge center is the octahedral void of what? Of the another unit cell, and this is the sixth octahedral void of another edge of the corner, the unit cell that is protruding or projecting from the corner. So this corner particle is surrounded by 1, 2, 3. This is 1, 2, 3 of the same unit cell and 1, 2, 3 of the neighboring unit cells. Totally how many octahedral voids are there? 6 octahedral voids are there. So every atom is surrounded by 6 octahedral voids and 8 tetrahedral voids. Now here is an interesting point, because I have talked so many things on tetrahedral voids so far. We have solved some problems also. And I asked you also to ask certain questions. You didn't ask. You kept quiet. Now I have a question. Or you could have asked like this. Sir, you told so many octahedral voids and so many tetrahedral voids are there in an FCC. 8 tetrahedral voids and 4 octahedral voids in an FCC. You could have asked as well, where are they? What are their locations? Now I told the location of octahedral void. In an FCC, the location of octahedral void are all the edge centers. So in FCC, how many octahedral void sites are there? We will make it very clear now itself, because it might be required for some other problems we are going to see later. This is a cube. These are all the particles at the corners, and face centers are also particles are there. FCC we mean. This is the particle of this face, and this is the side face, front face, and this is the top face. This gives you the diagram of an FCC. Okay. Now, where are all the octahedral voids? All at the edge center. So, hear me clearly, and you can ask the question very well. Some interesting point or some difficult point is also going to be there. Now, I said all the edge centers are the centers of octahedral void in an FCC. How many edges are there? Edges are 12. For any cube, how many edges are there? There are 12 edges. 1, 2, 3, 4 for one face. Likewise, if you calculate, this is front face 1, 2, 3, 4 for the back face, and this is 1, 2, and these are already calculated. These are 4. Totally 8 edges are there. How many centers are possible? Sorry, how many edges are there? 12 edges are there. 12 edge centers are possible. Okay. And one more octahedral void is possible, that is at the body center. So totally how many sites are there in FCC? 13 sites are there where octahedral voids are possible. Now I told just now there are only 4 octahedral voids, and now I am showing you 13 places for the octahedral voids. Just see here. Once I am telling that there are only 4 octahedral voids. Again I am telling that how many sites are there and the locations are there. There are 13 locations where octahedral voids are possible. Now am I contradicting? Once I say like that, once I say like this. Now I can show you that there are only 4 octahedral voids. What is that? Effective octahedral voids are only 4. Okay. Why effective octahedral voids are only 4? Because all these are edge center voids, octahedral voids. If there is a void, say of this type, that is shared by how many? Not only this does not entirely belong to this. In case there is a particle this in the octahedral void, that particle belongs to this unit cell, the neighboring unit cell, the above unit cell, and another neighboring unit cell here. So one edge is common, therefore edge center is also common for 4 such unit cells. Therefore, all how many octahedron void sites? 12 octahedron voids. Where they are at the edge center, they are shared by how many? Each edge center is shared by 4 such unit cell. Therefore, what is the contribution? Contribution of each octahedron void at the edge center is only 1/4 to the given unit cell. So 12 into 1 by 4 comes to how much? It comes to 3. Although there are 12 sites, although there are 12 octahedral voids, the contribution to the given unit cell is only 3. It is 12 into 1 by 4. And 1 is at the body center, that is not shared by other things. The full contribution of the void is going to be there. Totally, there are 4 octahedral voids in an FCC. Likewise, we will have to consider now, how about the tetrahedron voids? I said tetrahedron voids, how many are there? There are 8 tetrahedron voids. How could you say that? Because in FCC there are 4 particles per unit cell. Already I have said, in close packing there are 4 particles, then the number of tetrahedron voids double the number. 4 into 2, 8 tetrahedron voids. How many octahedron voids? The same number, that is 4. So in an FCC, 4 tetrahedron voids and 4 octahedron voids, 8 tetrahedron voids. Where are they? What is the site? Along the body diagonal. The location is along the body diagonal, and they are present along the body diagonal of the unit cell, and it is 1/4 each. The center of each tetrahedron void is located at 1/4 distance of the body diagonal from the corner, or both the TVs are situated, centers of tetrahedron void are situated equidistant from the center, body center. So one body diagonal contains how many? 2 tetrahedral voids. This is the center, this is the tetrahedral void, this is the tetrahedral void. Along the body diagonal, how many tetrahedral voids are? 2 are there. Where are they? They are not at the boundaries of the unit cell, they are within the unit cell along the body diagonal. How many body diagonals are possible? 4 body diagonals are possible. Therefore, total number of tetrahedral voids are 8. So this should be remembered. Now another body diagonal I can write like this. So its location will be here, and these are the 2 tetrahedral voids. One more body diagonal I can write like this. These are the 2 positions of that. And one more, of course, cannot be shown clearly here and here. So totally 8 tetrahedral voids are there inside the unit cell, and all the particle, in case they are present in the tetrahedral void, they are not shared by neighboring units, because the tetrahedron voids are inside the unit cell. A particle or a void is going to be shared by the neighboring units only if they are at the boundaries of the unit cell. TVs being not at the boundaries, they are not shared, and all the TVs belong to the same unit cell, and in case all the TVs are filled, then all the particles that are present in the TV belong to that unit cell only. They are not shared. So coming back to what? To sodium oxide structure, which I explained, anti-fluoride structure. There, sodium ions are present in the TV, tetrahedral void I told. How many sodium ions are there in sodium oxide unit cell? There are 8 sodium ions. All these 8 sodium ions, where are they? They are in the tetrahedral void, that means inside the unit cell. That is why they are not shared. Oxide ions, how many are there? They are oxide ions, they form FCC. There are 14 oxide ions to see. All the corners are oxide ions in sodium oxide, and all the face centers are also oxide ions. So it might appear that there are 14 oxide ions. No, you will have to consider the effective number, because they are all shared. Because octahedron void is where at the boundary. So how many octahedron voids? Now only I calculate they are 4. That is why how many oxide ions per unit cell? Per unit cell are only 4. So remember it very well. Whenever it is an FCC, there are 8 tetrahedron voids inside the unit cell, and any particle that is present in the tetrahedron void is not shared by other unit cell. Whereas octahedron voids, there are 4. Of the 4 octahedron voids, one octahedron void which is at the body center is not shared. Whereas 3 octahedron voids, effective octahedron voids, they are all octahedron contribution by the octahedron voids present at the edge center. Therefore, all the 3 octahedron voids are shared octahedron voids. If particles are present in these 3, they are shared. Now, with this much of information, we will come back to the problem. The problem is, so every atom or ion that forms, already I explained in case of what? In case of tetrahedron void. So a corner particle is surrounded by how many octahedron voids? 6 octahedron voids. 3 octahedron voids of the same unit cell and 3 more octahedron voids of the neighboring unit cells. So totally 3. So the geometry is going to be octahedron. Connect this all these, forms a square base, and if you connect all these, you will get an octahedron. So this corner particle is surrounded by 6 octahedron voids. Now what about this corner particle and the tetrahedron void? I'll show you separately, otherwise you will be confused. Now, where is the tetrahedron void? Along the body diagonal. Now, for this corner particle, what is the nearest tetrahedron along the body diagonal? 1/4 distance of the body diagonal from this corner, and there is a tetrahedron void. So, this corner particle is surrounded by 1 tetrahedron void along 1 body diagonal. Another tetrahedron void is away. It is not closer to that. Now, and one more, what is that? One more body diagonal I can write for the neighboring one like this, and there will be another tetrahedron void. And I can write one more body diagonal. Likewise, how many body diagonals can be written starting from or emanating from a corner particle? Starting from one corner particle, because one corner particle is going to be the common particle for 8 such unit cell, 8 body diagonals are possible. Understand it very clear. At the one corner is there, that is the common particle for 8 unit cells. So how many body diagonals can be written? Starting from that corner particle, 8 body diagonals of 8 unit cells. And each tetrahedron void present in one body diagonal is the closest member to that particle. Therefore, how many tetrahedron voids are closest to one particle? 8 tetrahedron voids are closest to one particle in FCC. Correct answer therefore is going to be first option, 6 octahedron voids and 8 tetrahedron voids. So understand it very well. In case you want to see the octahedron void in the model that I have shown already to you. Now this is the octahedron void. Okay. So in this diagram, in this model it is clear. In this model it is clear. So these are all the edge centers are the octahedron voids. This is the corner particle. There are 3 edge centers, 1, 2, neighboring 3. These are far off. 1, 2, 3 are the edge centers. Likewise, one edge center here, one more unit cell here, and one more unit cell here, one more cell up. So 3 more edge centers are possible. Totally this is surrounded by 6 octahedron voids. Now tetrahedron voids, this is the body diagonal, line joining this corner particle to this corner particle. And there is one tetrahedron void here. And another tetrahedron is here. So there are 2 tetrahedron voids along the body diagonal. There are 2 tetrahedron voids, one here and one here, and at the center there is one octahedron void. So totally along the body diagonal, here this is corner particle and this is TV, and here is what is that? Octahedron void. Again it is tetrahedron void. This is the corner particle. So what we can understand, a body diagonal is composed of, or total length of the body diagonal is the summation of what? It is equal to the radius of the corner particle into 2 radius of the corner particle, diameter of the tetrahedron void, diameter of the tetrahedron void plus the diameter of octahedron void. This should be understood. So along the body diagonal, 2 tetrahedron voids, 1 octahedron void, and 2 corner particles are going to be there. This information is required for so as to solve some other problems.